Okay, so we have learned earlier this week that we can go from standard form to the factor form by factoring, and we learned the different types of factoring from common factoring, difference of squares, and the sum and product. Today we are going to look at the quadratics in the factored form, and we're going to look at why do we think, or why is quadratic in the factored form important for this unit. So they give you two graphs here, and they're asking you to the key features of the graph. So if you look at the zeros for the first one, can you guys spot where the zeros are? So the zeros are the same thing as the x-intercept. So they are one right here and one right here. Yes? So your zeros are x-intercepts. They're x equal -2 and x equals -1. We're good with that? Now, what's your y-intercept for this one? At y equals 2. You see how it's very important to also write down the correct format. The axis of symmetry passes through the vertex. If I look at my vertex is right here, and my axis of symmetry is right in the middle between the two zeros, right? So it's between -1 and -2. So basically, my axis of symmetry is x equals -1.5. Sorry, I missed the vertex. If I look at the vertex, that looks like it's -1.5, and this is, it looks like -0.25. So it's a point at -1.5 and -0.25. What's the optimal value? What's the optimal value? So if you look at the vertex, the y value of the vertex is your optimal value. So it's y equals -0.25. Is that max or min? It's a min. Are we okay with this? So if we look at the second graph, again, we're looking for the zeros or the x-intercepts. What would be the zeros or the x-intercepts? I'm waiting for you guys. What are the x-intercepts for this? -3 and 1, yes. So if you look right here, the y-intercept, y equals 6. The vertex, what's the x value? -1, right? And then the y value is 8. So it's -1, 8. And the axis of symmetry is? What do I write? X equals -1. And the optimal value is y equals 8, and it's a max. Now, I want you to look at this, at these equations on the top of the graph. If you look at these equations, what form are these equations in? Are they in standard form? Are they in vertex form? Are they in factored form? Yes, in factored form. If you look at this, these are the three forms that we have been talking about. We talked about the standard form, which is it's the expanded form, right? That's the standard. So that's the expanded one. We talked about the vertex in the previous unit, which is y equals ax minus h squared plus k. And now we are moving from the standard to the factored by factoring. And we talked about it being y equals x minus r bracket x minus s. So when you have two things multiplied together in bracket. Okay, so if you look at this y equals x plus 2x plus 1 and y equal negative 2x plus 3x minus 1, that looks like the factored form. Yes? Now, my question to you guys, out of all the key features that we have talked about, which key feature is related to the factored form? The zeros, right? If you look at the x-intercept here, the x-intercept is negative 2 and negative 1, right? And in here, I see 2 and 1. Now, if I look at the x-intercept here, it's negative 3 and 1. And I see 3 and negative 1. So the zeros are in the factored form, but how are they in the factored form? They're the opposite sign, right? So if you look at this negative 2 is actually a plus 2 in my bracket. This negative 1 is actually a plus 1 in my bracket. And the reason for that, do you see the formula here? There's a negative in the formula. And what happens is when I have negative and negative, what does it become? Positive, and that's why it's x plus 2. When I have negative and negative, what does it become? Positive, and that's why I have a plus 1. In the other one, I have negative and negative, that makes it a positive 3. Negative and positive, that makes it a negative 1. So the reason why they're the opposite is because in the actual formula, which is y equal ax minus r, x minus s, it's a minus. So minus times whatever the sign is for the 0, right? That's why it's the opposite. Now, that being said, r and s, they represent your zeros. So if I know my zeros, I can make my formula, my equation. I can write my equation if I know my zeros. Okay? Because all what I have to do, let's say if your two zeros are, let's say if the zeros are x equals 4 and x equals negative 6, right? I already know my zeros. I can literally just plug them in, x minus 4 bracket x plus 6. Okay? If I know my zeros, all what I have to do is I replace my zeros into the letters R and S. Now I need to do one more step to solve for A, but that will be later lesson. Okay? Do you guys understand the factored form? Do you understand that from the factored form, I can find my zeros? Right? By looking at the equation, I can tell you what my zeros are. Because they're going to be opposite to what is inside the bracket. I'll show you how you can find these using steps. Okay? So, an equation in factored form, which is the form is y equals ax minus r, x minus s, tells the location of the x-intercepts, or the zeros. What you have to do, you have to remove the zeros from the bracket. So you have to set up each bracket equal to 0 and solve for it. Okay? I'll show you how we can do that. So, looking at this one, can you guys tell me what my zeros are? Positive 2 and negative 1. Here's a way that you can do this. This is not what the question is asking you right now, but I'm going to do this on the side. So in order for you to find the zeros, okay, you take each bracket and you set it equal to 0. So you're going to set this equal to 0, and you're going to set this equal to 0. Again, this is not what the question is asking you, so that's why I'm doing it on the side. So x minus 2 equals 0. To solve for x, you bring the negative 2 over, so it becomes a 2. If I have x plus 1 equal to 0, again, bring the plus 1 over, so x equals negative 1. Okay? That's what we do. This is how we solve for the zeros. Okay, what's the question asking you to do? Convert it to standard form, right? So factored form can be converted to standard form by doing what? What do I need to do to go from this form here to the standard form? Expand by, what's the process called? FOIL. That's right. So we need to expand. We learned this at the beginning of the unit, right? I need to expand. You guys need to understand when we learn something, we need to understand if the question is asking you to go from this form to this form, that's what I'm doing. Right? We learn it for a reason. So to FOIL this, we're used to, okay, I need to FOIL, so I need to multiply first by first, right? So I need to multiply my first, outer, inner, last. So I followed my FOIL process. And now what do I have to do? You can collect like terms inside the bracket. So plus x minus 2x, so that's minus x. Is that expanded fully, or I still have to do one more step? One more step, which is distribute the 3 in. Multiply the 3 in by everything inside the bracket. So it's going to be 3x squared minus 3x minus 6. So you see that now this is in standard form. So here's the question to you guys. Standard, factor. To go from standard to factored, what did we do yesterday and the day before yesterday? To go from standard to factored, what's the process called? You're going to have to factor. Okay? Either by common factoring or first and then or by difference of squares or by sum and product. To go from factored to standard, I have to expand or FOIL. Yes?
So when you're, the last part when you distributed the 3 into the other one,
Yeah.
the negatives don't matter, just do it times it by the number. So like it's not.
Yeah, because this is a positive and a negative, that makes it a negative. Right? Positive times negative is a negative. If that 3 was a negative, then it changes the sign. Right?
Be negative 3 times negative 2.
Yeah, which is positive 6. If it was a negative. Yeah. So factor y equals negative 3x squared plus 24x minus 48 to find the zeros of the relation. So what form is the equation in? Standard. You guys have to be able to pick these up fast, okay? You have to be able to look at it and see it's a trinomial, x squared, x and nothing. That's a standard form. When I go from standard to factored form, I have to factor. What are the factored, what did we learn? The method, the factored method. What do we have to do first? What's the first question you ask yourself? Do I have a greatest common factor? What's my greatest common factor here if I have one? Negative 3. If your first term is negative, you're going to have to factor that negative out. You can't leave a negative for your first term. Okay? So my greatest common factor is negative 3. I can divide 24 by negative 3, yes? Yes. I can divide 48 by 3, yes? You can try that on your calculator. Divide 48 by 3. See what you get. What do you get? 16, right? So yes, you can. As long as you get a whole number, then you can. So my greatest common factor here is negative 3. That means I have to divide each term by 3. Okay? So that gets me to y equals negative 3 bracket x squared minus 8x plus 16. You guys see that the terms, they switched signs because I'm dividing by a negative number. Now, after I took out my greatest common factor, what's the next question that I'm going to ask myself? Inside the bracket, do I have a binomial or a trinomial? Trinomial. Trinomial, that means I have to look at sum and product. If it's a binomial, what do I have to look for? Difference of squares. Okay? So trinomial, you look for sum and product. A binomial, you look if it's a difference of squares. Okay? So this is a trinomial difference of squares. That means I'm looking for two numbers that multiply to what and add to what? Multiply to 16 and add to negative 8. Okay? Since C is positive and B is negative, if you look at the green sheet, that means both of them have to be negative. Okay, so give me two numbers that multiply to 16. 4 and what? 4 times what? 4 and 4. Does 4 and 4 or negative 4 and negative 4, do they add to negative 8? Yes. Do I need to keep looking or can I stop and move on with my life and not waste time? I can stop because I can actually, this right away adds to negative 8, so I'm good, right? If I did not find one, so if I thought it's like negative 8 and negative 2, and that doesn't do it, so I just keep going, right? But if I already found my answer, why do I need to keep going? Right? So here's the answer. Because my factors are negative 4 and negative 4, then I can say, okay, that's x minus 4. This is how you factor. And then you put brackets, square root of x squared is x minus 4. Okay? Because in this case, both my factors are negative 4. So I will have to put them in my bracket. So it's x minus 4.
So you always carry the 3. Always carry the
Yes, the greatest common factor have to be carried out. Down. Okay, you don't get rid of it, please, because then you're changing your whole equality. Okay, then you're forgetting about your stretch because this causes your vertical stretch right there.
So you
right?
don't do anything with it.
No, you just keep it there. So now this is in factored form. The question is asking you, find the zeros. What are my zeros? What? What? Not negative. It's positive, right? Because remember, right now, I have to take this, equal it to 0. That's what the zeros mean. You take your factors and you equal them to 0, okay? So I took the factor, equal it to 0, bring the negative 4 over, so that's x equal to 4. Okay? I do the same thing for the other factor. Again, bring the negative 4 over, so x equals to 4. So in this case, how many zeros do I have? 1, because they're the same. They're going to overlap. So this is where the case that I have 1 0. Because with quadratic, you have different options. You have 3 options, actually. The options are, you can have 2 zeros, right? You see them right here. You can have 1 0, where the vertex is actually your 0, okay? Or I can have no zeros, and that would be if my vertex is either above the x-axis and opening up, or if I have like another case right here, right? It's below the x-axis and opening down. So there's 3 cases, okay? Cases where we have 2 zeros, cases that we have 1 0, and cases where we have no zeros. In this case, I have 1 0, which is that x equals 4. Are we okay with this? So, always, the question that you're going to ask yourself first when you're factoring, do I have a greatest common factor? What is it? Factor it out. If your first term is a negative, you want to factor out a negative. After you do so, you're going to look at your leftovers, what we call them leftovers, right? Which is whatever's inside the bracket. And then you're going to see if it's a binomial, so 2 terms, or 3 terms. 3 terms, you look at sum and product. Two terms, you look at difference of squares. And then you factor, then you solve for your zeros. Okay? Don't take the shortcuts to solve for the zeros because it's not always only the opposite sign. If you have a number in front of the x, you're going to have to solve for it properly. So here's an example. If I have, for example, this, y equals 2x plus 1 and x minus 2. What are my zeros? And this is why I said don't take the shortcut. The first one is wrong. It is not plus 1. Do not take the shortcuts. If I take this and I equal it to 0, I have to solve for x. So bring the negative 1 over. Is that x? No, that's 2x. I still have to do one more step, and that's dividing by 2. So my 0 is a negative a half, not negative 1. Don't take the shortcuts. Okay? For this one, yes, it is 2, right? But it took me like what? 3 seconds to write this? Better than losing a whole mark because I did not take that second.
So it would be 2.
So for this one, is x equal to. For this one, it's x equal to negative a half, so you have 2 zeros. Okay? But take the step, take the time to find your zeros. Okay, so here's what I want you to do. I want you to attempt B and C. Let's see what you can do. Write them in pencil.